Hello everyone. So for today, our group will share on how calculus can be applied to engineering. So first we will choose the calculus technique, which is the sequence, and we will choose this vehicle component, which is the car absorber. So how does these two relates to each other? So first, the car absorbers reduces the amount of energy whenever a car go through potholes or bumpy roads. So if any of you are wondering what does a car absorber looks like, so here we are sharing the pictures of the car absorbers. So this is the first one, and next this is the second one. So how does car absorbers relates to sequence? So we imagine that we have 6 different types of car absorbers, which each absorbing different amount of percentage of reduction in energy. So we will first choose the first one, which is 10%, and we'll choose the second one, which has 20%. The third one is 30%. The fourth one is 40%, and so on until 60%. So how do we make a sequence from this? So we imagine that whenever car go through these bumpy roads, the absorber will absorb this certain amount of energy, which is the initial energy, 100% energy. We will assume as 1. So here is the sequence for 0.1, which is 10%. And here is for 0.2, and now we will show the 30%, the 40%, the 50%, and the 60%. So now I will pass to my friend Amir to continue this video.
Hi, I'm Amir. For next part, I will explain on how to find the sequence ratio. As we know, the sequence that we got is a geometric sequence. Way to find the ratio are: divide each term by the previous term to determine the ratio. As an example, based on sequence of 10% absorption energy that we had calculated, divide the second term, which is 0.1, with the previous term 1, and you will get the ratio is 1/10. Apply the same method on every sequence to determine the ratio. Next question is, determine the absorber that's suitable for variety of terrains such as smooth road, bumpy road, or off-road. But the problem is, how can we find the most compatible absorber for each types of road? We have to calculate the amount of bounce for the absorber to reach the amount of energy that less than or equal to 0.1. As an example, using the sequence of 10% absorption energy, the amount of bounce for the absorber to reach the energy less than or equal to 0.1 is 1 bounce. And continue to find the amount of bounce for each absorber. Then we can decide which absorber is compatible for each terrains. For smooth road, the most suitable absorber is in between 10 to 30% of absorption energy. Meanwhile, for bumpy road, it is in between of 40 to 50% of absorption energy. And the last one, off-road, need a stiffer absorber, so the perfect one is an absorber that can absorb 60% of the previous energy. Lastly, plot a graph of amount of bounce against the absorption of energy.
I'm Fendi. That's all from us. Thank you.